file format. In Hadoop, by default, it is stored as text file, but we have many options to store our file using different file format. There are 5 other file format apart from text file. Sequence file format, RC file. Third one is a ORC. I'll tell you what is RC, what is sequence, what is ORC. Fourth and fifth are SERDI types, serialization and deserialization types. So let me write them as a inbuilt SERDI file format. Inbuilt SERDI. This is one of the important topic when you are talking about optimization. We have seen in earlier case different kind of map joining, then partition, bucketing, right? Now, using file format, how can you compress some data and reduce the space so that your network time can cut down and process or data can be queried as early as possible from your execution engine, whichever you are using. Inbuilt SERDI, we have two. First inbuilt SERDI is Avro, and second inbuilt SERDI is Parquet. So Avro SERDI and Parquet SERDI. Before that, before moving to SERDI part, we'll see how we can store data in a sequence file format. And there are few description between sequence, RC and ORC, because if I want to compare, just to using file format is one case. Second, which file you are using at what time, that is more important. So if you do not know what file is there, how to store that file, then you cannot utilize their all features properly, right? So let's do that. If I see sequence file, first one, we'll read the description. Hadoop performance is drawn out of when we work with a small number of file. Small number of file means they are saying we have file 1, file 2, and file 3. With big size rather than a large number of files with a small size. So this file 1, file 2, file 3 are 3 just file, but their size is very big. Maybe I have 10 TB of data. It's somewhere I have 100 GB of data. I have some 300 GB of data. This is what I'm calling. I have a big file and their data size is very high. That's what this means. Small number of files, a small number of files with a big size of data. Then second one is a large number of file with a small size of data. So it means I have file 1, file 2, file 3, file 4. I have a number of files, but their size is very less. Maybe I have 10 MB, 60 MB, 200 MB. This is what I'm calling as a small file. Size is small, but file number is high here. I have file 1 to a number of files. Now, when I have these two scenarios coming, then sequence file format is the best option to deal with, especially when file number is more, but the size is very less. If the size of file is smaller than the typical block, so we have seen this in the name node also. If I'm trying to store a small file, then it creates an overhead for name node metadata, because for every block metadata there is storing 150 bytes. So we have to be double sure that what is the size of data, because if I'm just writing the file which are 1 KB, 10 MB, 20 MB, their metadata overhead will increase, and which will create a problem for name node. To solve this problem, Hadoop is introducing the concept of sequence file, which is store the small file, small file into a container, right? This is what it is saying in a sequence file format. Sequence file are flat file consisting of binary key value pair. When Hive converts queries into MapReduce job, it decides on the appropriate key value pairs to be used for a given record. Okay, now how to create the table and how to store records in sequence file. Because if I read this theoretical, you can also do the job by your end. You can see this part. How practically we are proving this, that's more important. So I'll go to my Hive cell to open one terminal. Sudo hive. And here we'll see how we can deal with the sequence file. So databases, I'm using any database, let's say 12 PM. So tables, and I want to create a sequence file. Okay, so let me take some column description. What is their column name and what is their data type? So these are the column name and data types. Now I want to create a table. I'll say create table txn seq txn sequence, and I want to keep txn number as integer and customer number as integer. I'll take one more column as city string. Now here I need to write this stored as sequence file. This I will write it last. So row format delimited, fields terminated by, you can give comma, and stored as sequence file. If you create the table and check their DDL, so create table and table name, which is txn and seq. If I see their description, I can see their column name, their type of data storage is 30 types, file input format is sequence file input format, sequence file output format. Now, in any of this file format, remember, whatever file format we have discussed, in any of this file format, you cannot directly load a file. You cannot directly load a file. This load will not work. Always you'll have to insert it. Now, insert works in two ways. You can do one by one insertion from the query, or you can insert directly from a table. So insert works in two approach, one by one, using insert, insert override table name, select a star from table name. Otherwise, table one to table two. We already know how this insert does intra-hive communication, right? Table one to table two. That's what I'm going to do first. Table one to table two. So I have already one table, which is txn records, and I have created this table txn as a queue. Now I want to write this 3 column from txn record. Select a star from txn records limit 10. I'm just verifying whether we have data available in this or not. This is the data present, and if you want to see their description, you can use so create table name. This is a text file format, a plain format of file. Now I want to insert data into my table. Insert override table. What is the table name? txn underscore seq. Select a dot txn number, a dot cast number, a dot city. From txn records a, because I'm taking this result from source table, and this is the txn records table. Enter. Now record will be inserted, but it will store in a sequence file format. We'll go to HDFS and we'll verify our result also. And by the way, this is internal table. Well, we can create external also. We know the difference between internal and external now. We'll wait for the result. So query is done. We can see 50.055 seconds it has taken. Can we see result from sequence table? Select a star from SEQ, TXN, SEQ. These are the result set. Roughly 50,000 will have, because 50,000 result we have in TXN records. Now in HDFS, we want to check this HDFS, DFS, -ls. It is an internal table, so by default it will go to user hive warehouse /12pm.db database name, then SEQ folder name, and inside this will have processed input. If you see this result, and you can compare this with your previous txns file, I'll do that cat, and we'll try to see some result here. We'll say head. Now when I'm running a query, you can see this result, how these are converted into sequence file. Okay, now I'm more interested to see the size. So this is giving me total size of 1793363, though I have taken just 2 result from there. I can see my TXN records also, that whether they are taking more space or less space, but I should have an equal number of column in both the table. Currently, I cannot compare because one table has more column, second table has less column. But result you can see in a sequence file format. Similarly, there are RC file format and ORC file format. RC file format stand for record columnar. This RC file format stand for record columnar. What do we mean by this record columnar? So this is good. This file format is good for data analysis. Facebook itself using RC file format to store their data in Hive warehouse. Now, how record columnar can be used, and what individual property as an different than sequence in ORC we have in RC file. Let's read this. RC file stands of record columnar file, which is another type of binary file format which offers high compression rate on the top of the rows. So compression rate will be high, and if compression rate is high, which means my file will take less space. My file will take less space to store the data, right? RC file is used when we want to perform operations on multiple rows at a time. Yes, this is very important. When you are analyzing the multiple row at the same time, RC file are flat file consisting of binary key value pair, which shares many similarities with sequence file. The important point which we should remember is this. RC file first partitions rows horizontally into row split, and then it vertically partitions each row split in a columnar way. So your each row will be splitted. We'll see the result once our result is stored in RC file format. We'll go to HDFS and we'll verify this, how any result is coming in a columnar way. Because just looking at the description, things cannot be much clear. RC file first store the metadata of a row split. First you will find the metadata and then you will find the data. So it is giving you data in a key and value format. Now this column oriented storage is very useful while performing analytics. That's what I said, good for analysis. It is easy to perform analytics when we have high column oriented storage type. Facebook is using already this RC file. So similarly, as I have submitted a query for sequence file, I'll create one table for RC file. So tables, then let me see my email. I'll try to see some small column, a small table which has less number of column. We have just 2 column here. I think this is good. We can take this my email description. I will check desk my email, and I'll create one new table, create table, then email underscore RC. RC we're giving one extension so that we know, as an after underscore, so that we know this is RC file. I'll create name string, mail ID also string, then row format delimited, fields terminated by comma, and stored as RC file. Once this is done, then again same query I will run. Insert from this table. So insert into source table, which is email underscore RC, and you are taking two columns, a dot name, a dot mail ID, from table my underscore email, and enter. We'll wait for the result. This time it is taking this data from my email table and writing back to email underscore RC. Once this is done, check select the star from what is the table name, email underscore RC. We have got the same data, but in HDFS, how this data is getting stored, that's more important. First, I will see my underscore email and what is their size of file. Here I can compare because my both the table has equal number of columns. Email.txt and size you can see 130 bytes. Email underscore RC, that's my new table. Sorry, this will append directly with your database. So size, it is taking more. One thing is clear, this is taking more size. Now can we see the output and try to see what do they mean by splitting data from horizontally to row split and then writing their information. To see that, we'll use cat, and in cat, if you check this result, I can see this result in form of comparison they're using. Okay, that's I'm unable to read the whole record. I can see somehow some column name. Okay, so this is about your RC file format. Size, they are taking more than text file format. So good for analysis. They split your result horizontally and split the row result. So description you can read from here what RC file is doing. Third, ORC file. For ORC file, we'll create one more table. This is third file format, and I'll try to see some result from my employee. Select a star from my employee. Here we have three columns: name, salary, and age. Sorry, city. We can describe it also if you want to see the column name, salary, and city. I'll create one table. My create table emp underscore ORC. ORC stand for, just like RC is a record column and R. ORC is a optimized. ORC is a optimized row column. Optimized row column. You can see that optimized row column. Now emp underscore orc. I'll create the table, then I'll go back to orc file to read the description. Name, string, salary, double, city, also string. Then row format delimited, fields terminated by, I'll use this time tab as a field, and is stored as ORC file. Once the table is created, you can see that table description also. So create table name, was input format, was output format. Now let's write the data here. Same query. Insert query is exactly same as I'm just changing my table name, source and destination. Source table is my underscore emp. Sorry, source table is emp underscore orc, and destination table is my underscore emp. And I'm taking name, salary, and city. Name, salary, and city. Enter. We'll wait for the result again. We'll verify the data now. Select star from emp underscore orc. Go back to HDFS, and here it is emp underscore orc. Can we match the size here? So earlier it was my emp. Okay, so in ORC file format, okay, we can see the data. Zero, zero, and we'll see few result, first few result. Like this. So I'm trying to, okay, one second. My emp. So here it is emp underscore orc. These are your records in optimized row column format. Okay, so currently we're dealing with a small size of data, but in real time, if you read the description of it, I can perform for same for the table which is bigger, and you'll see they're reducing the size 75% almost. So optimized row column is we are using for optimizing our query. Then 75% roughly they decrease the size. So if your file size is 100 GB, it will optimize that file till 25 GB as a result and is stored in HDFS. Okay, so RC is the best file format if I compare in sequence and RC. I'll be using frequently ORC file format. If I talk about optimization and obviously the total space taken by your system. But obviously, if they're taking less space, so they're compressing your data or they're doing some kind of encoding in data side. That's why the size is less. And whenever you want to process any compressed file, your CPU takes more time compared to the text file format. Now, there are two other CERD types, Avro and Parquet. Now, Avro file format is serializing your data. So let me write one description here. Avro file format is serializing your data in row format. So when you are extracting data from RDBMS, like if using a scoop, you're extracting data from RDBMS and writing that data to HDFS. What is good? Avro is good because Avro is serializing data in a row format. So if data is stored in a row-oriented database, this can be faster. So if I'm taking data in directly into my data lake or a staging layer, Avro could be a better option compared to Parquet. Parquet we are using in HDFS almost everywhere, and Parquet is serializing your data in a columnar format. This is row format, this is a columnar format. So query wise, if I see, just we have compared this three file format, record columnar and optimized row columnar. This is faster than this two. If I run any query on columnar file, so compared to row oriented approach, columnar is much faster. We'll see both the type, Avro and Parquet. But one difference you guys can check, because I don't want to focus more on the theory side. You can read this Avro thing. I'll share the file. Or you can read orally fourth edition book also. You'll see that Avro and Parquet is having separate chapter. I'll start with Avro. What Avro data is present with us. I can start from a scoop also. Using a scoop, I can store my data in Avro file format. I think I have some data already present here. So let me check them first. HDFS, DFS -ls. And I have this data available in user Cloudera, I believe. Let me see, user Cloudera. Or can I check in the root itself? So patient Avro, I have some folder directory as patient Avro name, enter. So there is my data, part m 5 times 0.avro. Now I can see the data, and data and metadata both are present in this file. So Avro is combining your data and metadata both, right? Because if I go back to scoop and try to remember what my text file, sequence file, other format does, so text file is not extracting any metadata. Parquet and Avro, these are the only file format which will extract data along with the metadata. Can I see the result? Enter. So this is your metadata, this is your schema, right? Table is schema, and these are the data sets. Now I want to fetch this schema. So do we have any provision to fetch this schema? Now here we need Avro tool to download, and that is open source. It's available here, so you can go to Google and ask Avro tool. You can give the version, so you can check your Hive library, what version of Avro your Hive is using, and accordingly you can download. Mine is using 1.8.1, so I'm downloading this download. You'll get a link of jar download. Click on first link, then you can download the jar format. I have already downloaded and copied to my Cloudera, so I'll use that jar here. If you're downloading in Windows and you want to copy, you have WinSCP, CyberDuck, other FTP software option. So that tool is available in my desktop, and using this tool, I want to extract that data, that schema basically. Because if I do not know schema, then I cannot manage the table. And here is my query to extract the schema. Hadoop jar Avro tools. method you can call get schema. Then what is your file where you have stored your data? It's present avro. Let me see the extension. Present avro and part m avro. You'll have to exactly do the same and then write this schema somewhere in your home Cloudera desktop. I'll give a name as patient.avsc. This is the file name with a schema extension avsc. Once this is done, I'll open this file patient.avsc and this will extract all the metadata from this file and store in this patient.avsc. Let's open this vi patient.avsc. This is all my schema along with your other structures. Now I will have to write this data in HDFS in order to deal with data and metadata both. Now let me write this HDFS DFS. We know the command -put avsc file name and say you want to write this inside user. You can write anywhere, by the way. I'm using one directory location which is user. Now my data is present in present avro. I have extracted my schema. So three approach, right? If I write point wise, so three approaches required to deal with avro. First, extract avro file. If already you have present, then no need to extract it, just like in my case. Otherwise, you can use a scoop and take the data from RDBMS right to HDFS in a avro format. So how do you know that the file is having avro file format? You can see the extension of it. Second, download avro tool. I'm using tool version of 1.8.1, so you can check this from your user lib. There's a directory, and always this is very important in Hadoop because if you're using any other version, it may work, it may not work due to the compatibility versions. After downloading this, then I'm extract metadata from a file and metadata from file and store in local file system. Then fourth step, from LFS to HDFS, local file system to Hadoop distributed file system, write that information, write that schema. So far, I already performed this fourth step. So last step was put writing to user directory. All right. Now your job is done. Just one thing last, you have to create one table in Hive space. Now already have created one database for serialization data. I have the database name Sardi. Let me use this Sardi. And let's see if we have any data available. We have some table present. That's okay. But we'll create new table, create external table. Since my data is already present in HDFS, I'm writing external table. External table, avro present, and then no need to write the column name because that is unknown to us. Stored as avro, you can pass the data location, which is present underscore avro slash table properties. table properties where your schema is. And this is avro.schema.url is equal to, within single quote, I will write that location, hdfs colon double slash user, I think triple slash is there, user, and it was peasant.avsc if I remember correctly. Peasant.avsc. Let me give this peasant.avsc. Once you're done, semicolon, enter, and select star from table name. So if it went well, we'll see the data of Avro file format. So this is one approach to deal with Avro. Our second approach, you can, same way you performed with sequence file. And yeah, by the way, I can do insert, single insert also, insert into table name, which is avr underscore peasant. I can do this with sequence file, RC file, ORC file also. Okay, one by one insert. I have written this also. Insert works with one by one, like one insert operation at a time, table to table, which is known as a intra-hype communication. Insert into AVR peasant values. This is pure RWS query, and I'll write some result. Let's say 6. Then the name. Then what is the fourth? Looks like age. So let me give age. And what is their city? Semicolon. It will take some time since this is DML, and write this data to your table AVR peasant. Now, can we verify this result from HDFS? So HDFS DFS -ls peasant underscore avro slash part m000 dot avro. Use cat and see some data. Let's wait for this job. Once this is done, we'll read it then. Okay, this is for your previous file, and have we created a new file? We'll see it here. Underscore avro. I'll use ls command here. So this is my previous entry. You can see the date, and this is my latest entry. Because your Hadoop works with write once, read multiple, you cannot rewrite on the same file. So that's about Avro. You can take a schema, then you can write a table name, pass location, pass schema location, and then data can be managed. Otherwise, you can do insert. After that, last part is a Parquet. Now, Parquet data, I'll check first in my HDFS if I have any Parquet data. HDFS DFS -ls. I'll check this in user cloud era, because most of the time I keep there inside user cloud era. P history, I'll check very first table. So using a scoop, already I have done this extraction, and those part is already covered in a scoop session. So this is my Parquet file, and this is the metadata. If you want to see their metadata, you can go inside this folder, .metadata. Let me go inside .metadata. And this is your schema. Okay, table schema. Now, what is the difference between Avro and Parquet? In Avro, file and metadata both are residing together. Here I have a separate location. This is for data, and this is for metadata. Parquet is very easy because for Avro, we'll have to extract the schema, then write back to HDFS, then pass the location. Here it is already data is managed. I will just have to create one structure in my table. That's what I will do. Create table name. You will give a Parquet table name. So I'll create a table name, create table name. Can I give external table? Because data is present in different locations. So obviously external table is required. Create external table name, and I'll give a table name as peasant underscore Parquet. Peasant underscore Parquet 1. And their total column name. Since column name is not known to me, I can check from RDBMS. Or if you don't want to go to RDBMS, you want to check it from here, you have that option also available. Let me show you that option. Schema.avsc. Can we read this schema using cat command? I have ID name, age, city. That's right here. ID name, age, city. City is also string. Column name up to you, okay, how you're defining. But it's good if you're matching with the previous schema. It can deal directly. Sometimes it depends on the version, okay. Sometimes you get exception for a spell, but Hive is known as a case insensitive. So you will hardly get any exception if you're not writing the proper schema name. This is case insensitive. You can use uppercase, lowercase. Once this table description is given, then I will use this format, row format study. You have to remember this row format study. Whenever you're copying and pasting, check their special characters because encoding is sometimes different. So it may give you some error if it is not matching. Input format, output format, and last would be my data location. Where is my data location? I will write that value. This is user Cloudera. User Cloudera slash. This data is present in user Cloudera and P history. Okay, I can give name till this P history. It should take care of the record automatically. P history and semicolon. Select a start from table name, peasant underscore Parquet 1. I can see that data here. So my data is already present in HDFS. I'm just providing one schema with this inbuilt SERD option. What if I want to create one Parquet table and then from there I want to directly insert the record? I can do that also. Create table. Let's say this table name is txn underscore Parquet. And here I want to create txn number, which is integer, and I want to store amount, which is double. Then row format delimited, fields terminated by comma, stored as, you can give a file format Parquet, stored as Parquet. Similarly, if you want to create the table like this in Avro, you can do that, stored as Avro. So if I give you example of Parquet, I'll understand how Avro will work. Same way, just I need to change this insert stored as Avro. Now I'll insert data, insert override table txn underscore Parquet select a dot txn number, a dot amount from 12 p.m. This is my database name dot txn records, which is a. I'll give a condition also where amount is less than $100. Enter. We'll wait for the output. Once this is done, there are some result stored which I can confirm because I can see 2457547 rows written. Select the star from table, which is txn underscore parquet. Now, whatever data is present in this table, let me use limit 10. You can see it here, but if I go and check in my status directory, user hive warehouse, inside this database name, surdy.db, inside this table name. So data is stored in a Parquet format here. Check this result. First few lines using command head. This is your data stored in Parquet. Parquet takes a big size because always your column and R stores data in a bigger format because they keep they store your data in a sequence of columns. So this is pretty much your file format. Uh, file format by default is a text file format.